The Earth has always been a paradox, a sanctuary of life, and yet a stage for ruin. From its molten birth to the cradle of its oceans, it has carried the fragile spark of existence across billions of years. But beneath the surface of its beauty, there has always lingered a darker rhythm, the certainty that creation walks hand in hand with destruction. Every creature, from the tiniest bacterium to the largest leviathan, has lived under an unspoken truth that extinction is never far, that the world itself can turn hostile in an instant. Mountains rise, but they crumble. Seas nurture, but they can suffocate. Even the air we breathe has, in other ages, become poisoned up. Across deep time, life has been tested by trials that defy imagination. Oceans have boiled, stripping the planet of breath. The skies have turned black, veiled in ash and fire. Continents have trembled under the weight of volcanic fury, and from the silent abyss of space, projectiles have fallen with the force of gods, reshaping the planet in moments of unrelenting violence. Species have flourished only to vanish overnight, their worlds erased without warning. Entire kingdoms of life have been swept away, their legacy reduced to fragments locked in stone. Again and again, Earth has reminded its inhabitants that survival is not a promise, but a fleeting chance. And so, a haunting question lingers. Of all the cataclysms that scarred this planet, which was the most perilous? Which chapter of Earth's history was the darkest stage to exist upon? The time when life itself balanced on the knife's edge of annihilation. Before we journey deeper into Earth's forgotten past, pause for a moment. If this exploration into hidden worlds and ancient mysteries speaks to you, consider joining this voyage by subscribing. Each story is another step into the unknown, another glimpse into the forces that shaped life itself. This is the journey into Earth's most dangerous hour, a descent into the silence of extinction, and the fragile hope that still managed to endure. The first whispers of extinction were not found in books or theories, but in the stone itself. Quarry workers, shepherds, and explorers stumbled upon the remains of worlds no longer alive. In cliffs and riverbeds, in limestone quarries and coal seams, they unearthed bones of strange beasts that bore no resemblance to any living creature. Gigantic jaws, coiled shells larger than a man, imprints of ferns from forests that no longer grew. These silent relics hinted at an unsettling truth. Earth had once been home to forms of life that had vanished completely, to the early naturalists of the 18th and 19th centuries. This was a revelation almost too vast to comprehend. The prevailing belief was that life, once created, persisted in continuity, a divine chain stretching unbroken through time. But the stones told a different story, one of interruption, of sudden erasure. It was Georges Cuvier, the French anatomist, who gave this discovery its most chilling voice. Through meticulous study of fossilized bones, he declared that extinction was not only real, but violent. The fossil record, he argued, bore witness to catastrophic events, sudden upheavals that swept away entire species without trace. To him, the Earth was not gentle, but ruthless. His ideas met resistance. Across the Channel, the Scottish geologist Charles Lyell argued for uniformitarianism, the principle that the slow processes shaping the world today, erosion, sedimentation, the gradual shift of seas, had always operated in the same manner. Lyell's Earth was not a stage for sudden destruction, but a patient world sculpted by endless, gentle change. The debate between Cuvier's catastrophism and Lyell's gradualism was more than academic. It was philosophical, even theological. It asked whether history itself was a record of stability or of chaos, whether life's story was a tale of continuity or of repeated cataclysm. As the century turned, the young science of paleontology began to weave these fragments into a broader tapestry. Fossils were no longer curiosities, but pages of an ancient record. Layers of rock became volumes of Earth's history, each stratum preserving echoes of vanished worlds. Geologists traced sequences where flourishing ecosystems were abruptly replaced by emptiness, where reef-building corals disappeared, where forests turned to ash. These were not isolated anomalies. They were patterns. The fossil record began to reveal something both sobering and magnificent. Extinction was not rare. It was written into the very rhythm of Earth's evolution. Life surged, diversified, flourished, and then, without warning, it faltered, often in waves of devastation. Entire branches of the tree of life withered in moments geologically brief. What emerged was not a picture of stability, but of cycles, of creation entwined with loss. The concept of a geological clock deepened this realization. Stratigraphy, the careful study of rock layers, revealed that Earth's surface was a palimpsest, each layer recording a chapter of deep time. With the advent of radiometric dating in the 20th century, those chapters could be measured with astonishing precision. Decay of uranium into lead, of potassium into argon, revealed the true scale of time. Billions of years, punctuated by recurring cataclysms. The record of mass extinctions began to take shape. There was the Ordovician, when icy seas froze vast stretches of life. The Devonian, when oceans turned toxic and reefs collapsed. The Triassic, when ecosystems faltered after continental upheaval. And, of course, the most famous, the Cretaceous, when a cosmic projectile ended the age of dinosaurs. Yet even among these, one loomed darker than all others, the Permian. The Great Dying, when nearly every form of life was stripped away. The implications were staggering. Humanity had long believed itself part of a stable, divinely ordered creation. Now the rocks declared otherwise. Life was fragile, fleeting, perpetually vulnerable to forces beyond comprehension. Extinction was not a rare tragedy, but the norm. More than 99% of all species that ever walked the earth, swam its seas, or flew through its skies, were gone. Every living being was part of a vanishing procession, walking a narrow bridge between existence and erasure. For the first time, science confronted the possibility that life's continuity was not guaranteed. Survival was not a promise, but a precarious exception. In the depths of the Earth's stone record, humanity glimpsed a truth both terrifying and humbling, that the ground beneath their feet was paved with lost worlds, and that one day their own might join them. The recognition of extinction as a recurring force reshaped the human understanding of life's story. It was no longer possible to imagine Earth as a stable garden merely weathered by time. Instead, it appeared as a stage that had been reset again and again, each act of creation preceded by devastation. The bones and shells embedded in stone were not just curiosities of the past. They were memorials to vanished worlds, each one echoing the silence of an entire lost kingdom. For the scientists who traced these patterns, the revelation was unsettling. The fossils were not evenly scattered through the strata, as if sprinkled by chance. They clustered and vanished in abrupt intervals, marking horizons of disaster. A flourishing reef would appear, built by corals and trilobites, only to vanish in the next layer. Tropical forests filled with strange amphibians would give way to deserts barren of life. The evidence was not of a gentle decline, but of sharp endings. This was not a message easily accepted. The human mind prefers continuity, prefers to believe in progress and survival, yet the Earth's record revealed otherwise. Catastrophe was written into its very fabric. Even the scientists who championed gradualism found themselves facing undeniable gaps in the record. Sudden voids that no slow erosion could explain by the late 19th century. The philosophical weight of this realization began to sink in. If life itself could be swept away on such a scale, then humanity's place in nature was not secure. Species were not eternal. They were temporary, contingent, fragile against the forces of geology and cosmos. In lecture halls and books, the unsettling idea spread that extinction was not an anomaly, but the law of existence. The development of stratigraphy deepened this unease. Each layer of rock was like a page torn from a book that stretched into the abyss of time. And as scientists turned the pages backward, the story darkened. Periods of flourishing were brief interludes between collapses. Mountains rose and fell. Oceans advanced and retreated, and through it all, life staggered forward, repeatedly knocked down and reshaped. Then came the precision of radiometric dating. Suddenly, the scale of these catastrophes was no longer vague. The Earth was revealed as ancient beyond comprehension to 4.5 billion years old, scarred by 5 great extinctions and countless smaller ones. Some unfolded over millions of years, others in geological instants. The dating showed patterns, an almost rhythmic pulse of destruction that seemed to echo through deep time. The fossils, once dismissed as curiosities, now bore an existential weight. They were evidence that survival was not the rule but the exception. For every species alive today, there were countless others buried in silence beneath the Earth's surface. 99% of life's experiments had ended, their forms erased from the world forever. And still, one question lingered, heavier than all the others. Among all these catastrophes, which one had been the darkest hour? Which chapter of the record marked the moment when life came closest to complete erasure? The rocks whispered an answer, faint but undeniable. A time when the seas turned toxic, when forests burned, when more than 9 out of 10 species perished. The scientists who pieced together the clues gave it a name that carried the weight of its devastation. The Great Dying Dot, when the reality of extinction first settled into the scientific mind. It clashed uneasily with the prevailing vision of life's steady march. Charles Darwin, writing on the origin of species in 1859, had revealed a mechanism of change, natural selection, that explained how life diversified, adapted, and transformed across time. Yet even Darwin wrestled with extinction. He accepted it as part of the evolutionary process, but the sheer scale implied by the fossil record troubled him. How could the slow hand of natural selection, sculpting creatures across millions of years, coexist with sudden voids where nearly everything was lost? Extinction was too vast, too abrupt. It seemed less like the pruning of a tree and more like the torching of a forest. Among his contemporaries, skepticism endured. Many scientists were reluctant to accept catastrophes as part of Earth's narrative. Catastrophism smacked too much of biblical floods and divine punishments, stories of wrath and judgment woven into human myth. To embrace the idea that nature itself could destroy in sweeping acts of violence was to court a worldview both unsettling and dangerous. Uniformitarianism remained the safer path, the belief that the world was shaped by forces as gentle and gradual as rain on stone. rivers carving valleys, seas rising inch by inch. Yet the stones themselves resisted such comfort. Fossil beds began to reveal disturbing patterns. Entire assemblages of animals and plants were buried together, locked in the same thin layers of rock as though struck down simultaneously. Vast bone beds stretched across continents, filled with the remains of creatures that seemed to have perished in a single breath. These deposits carried the unmistakable scent of disaster. The search for causes began. Some scientists turned to climate, suspecting that great swings in temperature had once scoured the planet. Others looked to the seas, noting how shifts in ocean level could drown coastal ecosystems or leave them stranded in barren salt flats. Strange chemical signatures in stone hinted at episodes of suffocation, as though oceans had lost their oxygen and turned into watery graves. Still others pointed to volcanic ash preserved in layers, suggesting eruptions of unimaginable force. The human response to these revelations was a mixture of awe and fear. To imagine the world as a stage where entire kingdoms of life could be wiped away in moments was to confront the fragility of existence itself. The fossils no longer seemed like mere curiosities from another time. They became memorials to a past, steeped in tragedy, warnings etched into the bedrock. Philosophers and poets found in Extinction a troubling mirror. If the world had destroyed so much of its past, what guarantee was there for the present? Could the earth not turn against humanity as it had against the trilobites, the ammonites, the great forests of the Carboniferous? The notion unsettled not only science but culture itself, forcing a reappraisal of the planet's character. Earth was not the passive backdrop of life's story, it was an active participant, at times a violent antagonist, and as the layers of stone were read more carefully, a darker question began to emerge. If extinction was not a rare event, but a recurring force, then there must have been moments when the world tipped furthest towards silence, times when survival itself narrowed to the thinnest thread, when life teetered on the brink of erasure. Which of these catastrophes, then, was the deadliest of them all? The scientists of the 19th century could not yet answer. They saw only fragments, isolated beds of bones, peculiar gaps in the record, layers of ash and vanished creatures. But the pattern was there, waiting to be uncovered, waiting for future generations to trace it more fully. The idea of a great dying had not yet taken shape, but the seeds were planted. Earth's rocks held a secret darker than any myth, and those who studied them were beginning to sense the weight of the question they had stumbled upon as the 19th century gave way to the 20th. The unease surrounding extinction deepened. Fossil hunters uncovered ever more startling evidence of worlds undone. Vast quarries in Europe revealed layers where seashells and corals lay jumbled together, preserved in strange disarray, as if entire ecosystems had been overturned in a sudden collapse. In the American West, explorers unearthed bone beds stretching for miles, filled with the remains of ancient reptiles and mammals whose lives had ended together. The very scale of these finds defied explanation by slow erosion or gradual decline. Something abrupt had happened, something vast enough to strike down entire landscapes of life. Darwin's disciples, and the evolutionary biologists who followed, struggled to reconcile this evidence with the measured pace of natural selection. Evolution explained the branching of life, but extinction spoke of branches severed all at once. Could both be true? Could a slow mechanism of adaptation coexist with sudden strokes of annihilation? The debate was not merely scientific, it carried a philosophical weight. If nature could sculpt life with patience, but destroy it in a single catastrophic breath, then the story of evolution was not a steady ascent, but a fragile balance between order and chaos. Some scientists clung tightly to gradualism, hoping the evidence could yet be bent into its framework. They suggested that bone beds were the product of floods, storms, or migrations, local tragedies stretched over centuries rather than planetary convulsions. But others, armed with new tools of geology, began to see the patterns differently. The strata spoke not of isolated accidents, but of repeated collapses, each one global in scale. The same horizons of death appeared in distant lands, separated by oceans and continents, yet echoing the same story of sudden loss. By the early 20th century, the evidence was undeniable. Extinction was not an occasional curiosity, but a fundamental force in Earth's history. And yet the cause remained elusive. Some suspected vast shifts in climate, cycles of ice and heat that could overturn the stability of ecosystems. Others considered volcanic eruptions of unimaginable scale, their ash clouds capable of dimming the sun and starving entire biospheres. A few whispered of cosmic origins, collisions with objects from beyond Earth, though such ideas remained too speculative for serious acceptance. What gripped the scientific imagination most was the sheer magnitude of loss. Fossil evidence suggested that entire lineages had been erased in a single horizon of stone, with only fragments continuing into the next. The trilobites, once masters of the oceans, dwindled and vanished. Coral reefs, which had flourished in warm, shallow seas, were left as broken ruins. Amphibians that had dominated swampy forests gave way to silence. Again and again, the pattern repeated: abundance, collapse, renewal, but always with most of the old world lost, for humanity still. New to the perspective of deep time, the realization was sobering. It placed the present within a procession of worlds that had already perished. The age of mammals, the rise of humankind, no longer seemed inevitable but provisional. One more chapter in a book where endings were written in advance. If 90% of species were gone, then the living world was not a permanent inheritance, but a temporary reprieve. And so, from these early reactions, a darker curiosity began to take root. If extinctions were woven into the planet's story, then there must have been moments when that story came closest to its end. Among all the collapses written into stone, which was the most devastating? Which time marked the greatest narrowing of life, when the Earth came closest to a silent planet? The search for that answer would drive paleontologists, geologists, and biologists across the next century toward the discovery of an ancient catastrophe so immense it would be called simply the Great Dying. The 20th century brought with it a sharper lens for reading the Earth's ancient record. No longer were fossils seen as scattered curiosities. They became markers of time itself, milestones in the planet's long memory. With careful study, scientists began to notice a disturbing pattern written across the ages. Extinction was not only frequent, it was periodic, recurring like a heartbeat, each pulse reshaping the course of evolution. As geologists and paleontologists pieced together this story, they identified 5 moments when life faltered on a scale beyond comprehension. The Ordovician, when icy seas entombed the planet and stripped the oceans of their bounty. The Devonian, when shallow seas collapsed and the reefs that had flourished for millions of years dissolved into silence. The Triassic, when a world struggling to recover was struck again, reshaping ecosystems before the rise of the dinosaurs. And the Cretaceous, when a cosmic blow ended the age of giants and opened the way for mammals to ascend. Yet among these catastrophes, one stood apart. The Permian. 250 million years ago, life on Earth came closer to total erasure than at any other moment. More than 90% of species disappeared, both in the seas and on land. Forests vanished, reefs collapsed, insects themselves, the most enduring architects of resilience, dwindled in terrifying numbers. It was as if the planet had turned against life in every form, erasing nearly all that had evolved in the hundreds of millions of years before. The first clues came from the fossils. In Permian layers, thriving communities of creatures were abruptly replaced by emptiness. Trilobites, which had survived every upheaval for nearly 270 million years, vanished completely. Coral reefs that had built vast undersea cities crumbled and never returned in their ancient form. Amphibians that once filled rivers and swamps gave way to silence. The continuity of life broke in a way more profound than at any other time. But the question of how this devastation unfolded lingered like a shadow. Was it a sudden cataclysm, striking down life in a single violent episode? Or was it a slow unraveling, a long decline stretched over millions of years? The debate grew fierce. Some saw evidence for gradual collapse, subtle changes in climate, a slow poisoning of oceans, an erosion of ecosystems until they could no longer hold. Others pointed to layers where entire groups vanished in a geological instant, as though struck by an unseen hammer. The truth seemed to hover somewhere between a catastrophe, both sudden and stretched. Waves of destruction that cascaded across the planet. The rise of geochemistry offered a new language to probe the silence of these ancient rocks. Isotopes preserved in sediments revealed sudden shifts in carbon cycles, fingerprints of vast disruptions to the atmosphere and the seas. Oxygen levels plummeted in the oceans, leaving vast stretches of water anoxic, lifeless, suffocating. Evidence. A volcanic activity emerged, not from modest eruptions, but from something far greater. Entire provinces of basalt. Vast sheets of lava that once erupted across Siberia, covering millions of square kilometers. These eruptions lasted hundreds of thousands of years, releasing carbon dioxide, methane, and toxic gases in volumes beyond anything humanity has ever imagined. The more scientists studied, the darker the picture became. The Permian was not merely an extinction, it was near total annihilation. A collapse of systems so fundamental that even the insects, the survivors of nearly every crisis before and since, faltered in their diversity. The seas became toxic, the skies darkened, the forests burned, and life, which had always endured, nearly failed. It was here that scientists first grasped the magnitude of the question they faced. If the history of Earth was written in extinctions, then the Permian marked the deepest scar, the moment when existence itself came closest to silence. It was not just another chapter in the rhythm of destruction. It was the brink of life's undoing, the most dangerous time the Earth had ever known. As evidence accumulated, a grim realization began to take shape. The Permian extinction was not confined to one region, nor limited to a single environment. Its fingerprints appeared across every continent, in every ocean, in nearly every type of rock studied. Fossil beds from China to South Africa, from Russia to North America, all carried the same tale of devastation in South Africa's Karoo Basin. Paleontologists uncovered layers where once thriving reptilian lineages, the great therapsids, distant ancestors of mammals, vanished in successive pulses. Species that had dominated landscapes for millions of years disappeared, leaving behind only a sparse scattering of survivors. In marine strata of China's Maishan region, geologists traced the sharp boundary of extinction, where diverse communities of shellfish, ammonites, and reef builders gave way to sudden emptiness. These death zones became haunting landmarks. In stone, silent witnesses to a global catastrophe, the discovery of so-called coal gaps further deepened the mystery. For tens of millions of years, Earth's lush forests had left behind thick seams of coal, evidence of teeming plant life. Yet, in the aftermath of the Permian, this record vanishes almost entirely. Forests that once covered the continents were reduced to ashes, and for millions of years afterward, coal deposits are scarce. The silence of the coal seams became another line in the chorus of absence, proof that Earth's biosphere itself had collapsed. The emotional weight of these revelations was profound. Extinction was no longer a distant concept, abstract and mathematical. It was a visceral reality written in ash and stone, the obliteration of entire worlds, entire kingdoms of life. For scientists of the 19th and early 20th centuries, the realization was unsettling, almost unbearable. How could nature, so intricate, so resilient, suffer such near-total defeat? If evolution was a grand story of progress, then the Permian showed it was equally a story of collapse, where even the most successful forms of life could be erased in an instant. The debates deepened. Some argued that such destruction must have been sudden, a comet, perhaps, or a singular event of cosmic scale. Others insisted on gradualism, a long suffocation of ecosystems under the relentless weight of volcanic gases, rising seas, and shifting climates. Yet as geochemistry advanced, the subtle record of isotopes, trapped in minerals for hundreds of millions of years, began to tilt the balance. Carbon isotopes revealed massive injections of greenhouse gases, consistent with the eruptions of the Siberian traps. Sulfur isotopes hinted at atmospheric poisoning, clouds of aerosols that darkened the skies and acidified the rains. Oxygen isotopes showed warming seas, then stagnation, then suffocation. It became clear that the Permian was not a single moment, but a sequence, waves of destruction rippling through the biosphere. The eruptions may have lasted hundreds of thousands of years, yet their consequences cascaded faster than ecosystems could adapt. Each pulse of lava released more carbon, driving temperatures higher, stripping oxygen from the seas, killing off species that had barely begun to recover. From the last wave, the Earth itself became unstable, its cycles of carbon, oxygen, and nitrogen spiraling into imbalance. In this light, the Permian extinction emerged as more than just an event. It was a turning point in the history of life, a reminder that the Earth is not a passive stage but an active force, capable of remaking itself in fire and silence. Scientists began to see it not as a singular mystery, but as a lesson that stability is fragile, and the forces that sustain life can, under pressure, unravel into chaos. And yet, amid the ruins, one truth offered a glimmer of resilience. Life did not vanish entirely. A small fraction endured the ancestors of modern reptiles, the roots of the earliest conifers, tiny survivors that clung to existence in the margins of catastrophe. From this remnant, the Earth would recover, reshaping itself into a new world, the age of reptiles, and eventually the age of mammals, would rise from the ashes of the Permian. But the haunting question remained: how close did life come to ending completely? If 90% of species vanished, what invisible line kept The remainder, alive, was survival the product of chance, geography, resilience, or some deeper law within evolution itself? For the scientists who pieced together these clues, the Permian extinction became a puzzle not only of the past, but of existence itself. The Big Five mass extinctions had been named, but the Permian stood above them all, the dark summit of destruction. It was, as one paleontologist described it, the moment when the Earth nearly died. The riddle of the Permian extinction began to sharpen into focus with one of the most formidable discoveries in Earth's deep history, the Siberian traps. In the frozen expanse of northern Russia lies a scar of unimaginable scale, a volcanic province that once stretched across millions of square kilometers. To walk upon it today is to tread on stone that was once liquid fire, hardened waves of basalt stacked kilometers thick. But these dark rocks are not merely the remnants of ancient eruptions. They are the fossilized heart of a cataclysm. And 52 million years ago, fissures split the Earth's crust in violent succession. From them poured molten floods, not for years or centuries, but for nearly 1 million years. Lava covered entire landscapes, drowning forests, burying rivers, sculpting new mountains of fire. The volume of rock expelled was so vast that, if spread evenly, it could have buried the entire planet beneath a sheet of incandescent stone, many meters deep. But the fire alone was not what killed. It was what the fire unleashed. As molten rock surged upward, it burned through thick beds of coal, oil, and carbonate. Each contact zone became a crucible, releasing colossal quantities of carbon dioxide and methane into the skies. The atmosphere, thickened with greenhouse gases, trapping heat, distorting climate, bending Earth's cycles of life beyond recognition. GEOCHEMICAL, signatures locked in minerals, tell the tale. Ratios of carbon isotopes plunge abruptly, signaling an injection of carbon unlike anything in Earth's prior history. Oxygen isotopes in ancient shells shift sharply, marking a rise in global temperature that may have reached 10 degrees Celsius, a fever in planetary terms, enough to destabilize every ecosystem at once. In some places, tropical seas became so hot they neared the limits of life itself, water approaching the temperature of a bathtub, suffocating corals, mollusks, and fish in thermal shock. The oceans, once Earth's cradle of stability, turned hostile. As warming stripped oxygen from the seas, vast stretches fell into anoxia, dead zones where even the most resilient marine creatures could not survive. In this water, archaic microbes flourished, releasing hydrogen sulfide, a poisonous gas that may have drifted into the atmosphere, tainting the very air animals breathed up above ground. The rain turned acidic. Sulfur and chlorine from the eruptions mixed with water vapor, falling as caustic storms that scoured the land, bleaching soils, withering forests, dissolving the fragile tissues of plants before they could seed a new generation. Fossilized soils from this period bear the scars, warped mineral layers etched by acid rainfall, a silent record of poisoned skies. The devastation reached even the roots of the biosphere. Fungal spores explode in the fossil record at the boundary layer, a sign of decay overwhelming growth. Forests collapsed, leaving behind little more than rotting debris fields. Coal formation, the geological bookmark of thriving plant ecosystems, nearly ceases. For millions of years, the Earth's landscapes were barren, unable to restore the lush carbon-trapping greenery that once blanketed the continents. Reefs, too, long architects of marine ecosystems, suffered near total obliteration. Once vast, carbonate structures, alive with corals and sponges, vanished almost overnight, leaving empty seafloors where life had once clustered in dazzling complexity. It would take tens of millions of years for reefs to rise again, a gap in time so immense it dwarfs the span of human civilization. The fingerprint of volcanism was everywhere. Geochemical traces, spikes in mercury, an element released in huge quantities by eruptions, appear in rocks across the globe, from Greenland to Antarctica. Each spike is a flare, pointing back to the same source, the Siberian traps. Layer upon layer of volcanic ash confirms the timing, matching precisely the moments when ecosystems collapsed. For decades, scientists debated whether volcanism alone could explain such annihilation. But as the evidence deepened, the picture grew harder to resist. Here was a chain reaction written into the fabric of the earth. Fire giving rise to gases. Gases reshaping climate. Climate dismantling life. The Permian extinction was no simple accident. It was Earth's chemistry turned against itself. A planetary feedback loop spiraling into catastrophe. And yet, in this realization, there was something profoundly unsettling. For it meant that destruction on this scale required no comet, no alien intervention, no hand of the divine. It required only the Earth itself, its restless mantle, its volatile atmosphere, its delicate balance of gases and oceans. The catastrophe was not an anomaly. It was a potential written into the very physics of the planet. The more the record was examined, the clearer the consensus became. The Permian extinction was Earth's darkest hour, a near-total collapse of the biosphere driven by a volcanic inferno that turned the world into a greenhouse tomb. But even this was not the full truth, because hidden within the sediments were subtler signs, whispers of methane hydrates, thawing from the seafloor, releasing their potent greenhouse gas in bursts that magnified warming. Others found evidence of trace metals, nickel, arsenic, lead drifting into ecosystems, slow poisons carried on volcanic winds. Each new clue added another layer of horror, painting the Permian not as a single disaster, but as a cascade of overlapping terrors. And the haunting question remained, if life could endure this, just barely, how fragile must the threshold of survival truly be? Underneath the quiet stones of the Permian boundary, the evidence grows more intricate, as if the earth itself is whispering the full story in fragments, waiting for patient hands to assemble it. The volcanic fire was the spark, but what followed was a chain reaction, an orchestra of destruction where each element magnified the other. Scientists now believe the Siberian eruptions not only released vast carbon dioxide, but also drove the oceans into runaway collapse. Methane hydrates, crystalline cages of water, and methane frozen into the seafloor began to thaw as temperatures rose. When destabilized, they released their contents in sudden, violent pulses. Methane, a greenhouse gas far more potent than carbon dioxide, surged into the atmosphere. In this amplification lay the deadly genius of the Permian catastrophe. Carbon warmed the world. That warming freed methane. Methane in turn supercharged the warming, driving yet more methane release. It was a planetary feedback loop, spiraling with no natural break, a self-sustaining fever with no chance of recovery until nearly everything was gone. The sky, too, bore scars of collapse. Ozone, Earth's fragile shield against ultraviolet radiation, may have thinned to tatters under the chemical assault. Studies of fossil pollen show strange deformities, their shells warped and blistered, as if burned by unseen rays. If the ozone layer did falter, then forests and shallow seas would have suffered doubly. Not only scorched by heat and acid, but seared by ultraviolet light from the unfiltered sun. The poison was everywhere. Heavy metals, volatilized from magma, and carried across continents, infiltrated rivers and soils. Mercury levels spike in rocks from this time, a geochemical signature of volcanic breath. Traces of arsenic and lead accompany them, slow killers that would have infiltrated food webs. Compounding the crisis, the fossil record responds with chilling silence. In layer after layer, once thriving communities vanish. Trilobites, survivors of hundreds of millions of years, meet their end here. The great corals that built warm water reefs disappear, replaced for a time by microbial mats. Even insects, those most resilient of Earth's wanderers, suffer their only known mass extinction, with entire orders lost forever. And still, perhaps the most haunting clue lies in the pattern itself. Some deaths came swiftly, in sudden pulses, that scythed through oceans and forests. Others stretched across tens of thousands of years, as if life clawed toward recovery only to be struck down again by another surge of volcanic fire. The extinction was not one blow, but a rhythm, a grim cadence of eruptions, warming, collapse, and silence. When the final echoes faded, more than 90% of marine species were gone, and nearly 3/4 of all life on land. The biosphere, once intricate and abundant, was stripped to its barest bones. What followed was not immediate rebirth, but a long, desolate silence. For millions of years after the Siberian traps ceased their fury, the earth remained sick. Deserts, spread across continents once clothed in forests. In the seas, strange hardy creatures eked out survival, while true complexity struggled to return. It was as though the planet itself had been reset, its ecosystems erased, its evolutionary pathways forced to begin a new dot. And in this silence, one truth emerges. The Permian extinction was not simply the end of species. It was a reshaping of possibility, a narrowing of futures. Every creature alive today is descended from the small remnant that weathered that storm. The inheritance of survival belongs to a fraction of life, carrying forward a story written in fire, in poisoned seas, in air that once turned against its makers. The consensus hardened across decades of research. Here was Earth's darkest hour, a catastrophe not driven by impact from the skies, but by the planet itself, tearing open its depths, drowning its air in fire, and nearly undoing all that billions of years had built. Yet within that consensus lingers unease. If the Earth could once destroy so much simply by the restless stirring of its mantle, then the boundary between stability and annihilation is far thinner than it seems. The Permian extinction is not only a story of the past, it is a mirror held against the present and against the uncertain future of life on this restless planet in the aftermath of the Great Dying. When silence had settled across oceans and continents, a haunting question began to echo through deep time. Why did some endure while nearly all else perished? The Permian extinction, though vast in its reach, was not absolute. Scattered among the ruins of life, fragile threads of survival persisted. A handful of reptiles clung to the land, a few hardy fishes swam in poisoned seas, and in the shadows of catastrophe, ancestors of creatures that would one day inherit the earth found sanctuary. The pattern of survival has long been a mystery that troubles the mind. Was it mere chance, a roll of nature's dice? Or did certain qualities, tolerance to heat, resilience to low oxygen, an ability to burrow into the earth, or retreat into the depths of the ocean determine which species crossed the threshold. The fossil record reveals a strange unevenness. Lineages seemingly robust vanished without trace, while small, obscure creatures found ways to endure. It is as though evolution itself was blindfolded, choosing its survivors not through strength or dominance, but through subtle traits of endurance invisible to the eye. The tempo of extinction deepens this mystery. Was it a single apocalyptic moment, a swift scythe cutting through the web of life, or a series of rolling catastrophes, each wave undoing what little had survived the last? Evidence suggests both. Certain fossil layers speak of sudden, sharp collapses, while others reveal drawn-out declines. Ecosystems staggering, recovering faintly, only to fall again. It was less a single ending, and more a grim cadence of death spread across hundreds of thousands of years, an age when life seemed trapped in a slow-motion collapse. But there are clues that the kill mechanisms were more varied than fire and heat alone. As the oceans stagnated, microbial empires rose. Ancient bacteria, thriving in oxygen-starved seas, may have exhaled hydrogen sulfide in lethal clouds. This invisible gas, both toxic and corrosive, could have seeped into the atmosphere, spreading the ocean's death outward across the land. In such a world, the air itself would have been poison. Geological records whisper of yet another danger. Some scientists suggest that Earth's magnetic field, the invisible shield that guards the planet from cosmic radiation, may have faltered during this time. If the magnetic field weakened, then the planet would have been bathed in a harsher rain of cosmic rays, destabilizing climates, damaging DNA, and amplifying stresses already at the edge of tolerability. Others turn their gaze upward, beyond Earth's own restlessness, to the star that nourishes all life. The sun, they suggest, may have played a role. Periods of heightened solar activity, bursts of radiation, and flares far greater than those humanity has ever witnessed could have compounded the disaster. In this vision, Earth was not merely betrayed by its interior fire, but scorched by the very star that gives it light. Each of these threads adds to the tapestry of dread. Toxic seas, collapsing forests, skies darkened by ash, air laced with poison, radiation from above, heat rising from below. It is a vision of Earth transformed into something alien, a planet that no longer welcomed the creatures it had raised. In this time, the very conditions of habitability unraveled. The familiar became hostile. The home world itself turned predator, and perhaps this is the most profound terror of the Permian extinction. Not that life ended, but that the Earth itself became unfamiliar to its own inhabitants. Oceans once teeming with reefs turned into suffocating basins of green and purple bacterial scum. Forests that had stretched for continents crumbled into deserts. The air itself became a weapon, the sun a threat, the ground unstable beneath the feet. For millions of years, the planet was no longer Earth as life had known it, but a stranger, alien, indifferent, and lethal dot. Yet within this alien world, resilience still found a way. Certain burrowing creatures, shielded underground, weathered the storm. Some fishes retreated into oxygen-poor refuges where they had always dwelled. Microbes adapted, thriving in niches that destruction had opened. Life, though shattered, never fully surrendered. It waited, diminished, for conditions to ease. The mystery of survival is thus not only scientific but deeply philosophical. Why these few and not the many? Why was the thread of continuity not cut entirely? In the ruins of catastrophe lies a strange paradox. The world became unrecognizable, and yet, within that alien wilderness, seeds of the future endured. The great dying reveals a truth both humbling and unsettling. Life does not persist because Earth is safe, or because the cosmos is kind. It persists because even in the harshest crucible, some small fraction of being clings to existence, defying the odds. Carrying the story forward, the Permian extinction reminds us that survival is not guaranteed. It is a razor's edge, balanced on forces far beyond the scale of any living thing. And in those precarious balances, history itself is written. The deserts of Siberia, the cliffs of South Africa, the salt flats of China. In these places, the scars of the great dying are still etched into stone. Geologists and paleontologists have learned to read those scars as though they were lines of a book, each layer of sediment a page in Earth's darkest chapter. To walk through these sites is to walk backward in time into the silent ruins of ecosystems that collapsed long before humanity emerged. In the Karoo Basin of South Africa, paleontologists kneel over slabs of ancient shale, brushing dust from bones that once belonged to therapsids, mammal-like reptiles that dominated the late Permian. Some of these skeletons are frozen mid-stride, as though death had struck suddenly, leaving no time for escape. Others are found in crowded clusters, entire groups perishing together, suggesting environments that betrayed whole communities at once. The rocks here reveal not only death, but the tempo of decline. Ash layers hint at distant eruptions, while fossil pollen shows forests dwindling until they vanish altogether, far to the north. In Siberia, the land itself tells of the inferno. Vast stair-step formations of basalt stretch across the horizon, relics of the Siberian traps eruptions that poured fire upon the planet. To stand here is to stand in the aftermath of planetary violence. Flows of lava stacked higher than mountains, stretching across millions of square kilometers. Geochemists chip at these ancient rocks, seeking isotopic fingerprints, spikes of carbon that mark runaway warming, or traces of nickel and mercury that signal volcanic emissions spreading toxins. Through land and sea, each sample becomes a clue, a fragment of the puzzle. The oceans, too, preserve their memories. In South China, limestone cliffs harbor thin black layers of carbon-rich shale, silent witnesses to an ocean that once suffocated. Within them lie fossils of brachiopods, once as common as shells on a beach, now preserved as sudden absences. For millions of years they thrived, carpeting sea floors, but within a geologic blink they vanished. Alongside them, trilobites, survivors of earlier crises, disappeared entirely. Their 250 million year lineage erased in the span of the Permian's final catastrophe. When geochemists dissolve these shales in their laboratories, strange stories emerge. Ratios of carbon isotopes show wild swings, evidence of massive injections of greenhouse gases. Sulfur isotopes hint at bacterial blooms, microscopic killers that thrived in stagnant seas. Iron deposits shift from signs of oxygen-rich waters to signs of anoxia, painting a picture of oceans that became vast, stratified tombs. The chemistry of the rocks becomes a language, and though ancient, its meaning is unmistakable. Earth's systems were not merely stressed, they were overturned, and yet, within the same rocks, the faint pulse of survival is recorded. Tiny, conodont teeth, barely larger than grains of sand, reveal that some fish endured the suffocating seas. Fossil burrows hint at small creatures retreating underground, carving out hidden refuges in poisoned landscapes. even spores from hardy plants, whisper that pockets of green persisted when the forests fell. These traces are fragile, but they tell of continuity, thin lifelines stretched across an abyss. Debate still stirs over whether the catastrophe unfolded in waves or in one climactic blow. Some layers suggest a staggered collapse, forests faltering, then seas choking, then the skies turning hostile. Others argue for suddenness, that the system crossed a threshold, unraveling in cascading failure. Perhaps both are true. Perhaps the earth bled slowly, until a final convulsion ended the world as it was. Yet the deeper mystery remains. Why resilience favored some and not others? Was it physiology, the ability to survive with little oxygen, to burrow, to feed on detritus rather than lush vegetation? Was it a chance, the geography of being in a pocket less touched by catastrophe? Or was it, as some suggest, a matter of ecological simplicity? Generalists thriving where specialists starved, scientists peering into fossils and isotopes, search for answers, but the silence of deep time offers only fragments. The truth may be layered, hidden, and never wholly revealed. What is clear is that resilience was not about dominance. The rulers of the Permian, towering forests, reef-building sponges, vast herds of theropsids, were the ones most undone. Survival belonged to the small, the adaptable, the overlooked. The earth that emerged from the Permian's crucible was no longer the same. Its forests were gone, its reefs destroyed, its dominant lineages broken. And yet, in that vacancy, new chapters were prepared. Out of the survivors, new ecosystems would rise, carrying within them the memory of collapse. The mystery deepens because it is not only about the past. To study this ancient extinction is to confront the unsettling possibility that life's endurance is fragile, its continuance uncertain, its survivors unpredictable. The Permian reminds us that even the most abundant, the most established, the most dominant forms can vanish when the world itself shifts against them. And perhaps this is why the great dying still haunts science. It is more than a puzzle of ancient stones. It is a mirror showing that survival is never a certainty, that habitability itself can be lost, and that Earth, the cradle of life, can at times become its executioner. The fossil record is filled with shadows of endings. Again and again, life has risen to flourish, only to be cut down in sudden silence. The end Cretaceous, marked by the Chicxulub asteroid, is the most famous. A mountain-sized rock from the sky, striking with the force of billions of nuclear weapons, plunged Earth into a shroud of fire and darkness. Dinosaurs, masters of their age, were undone in days. Their dominion ended not by weakness, but by chance. Yet even this great calamity pales beside the scars of the Permian. Chicxulub was a singular blow, sharp, violent, decisive. The Permian was something else, a slow strangulation, a chain reaction of Earth's own making. A volcanic wound bled for nearly 1 million years, rewriting the atmosphere, boiling seas, and corrupting the very chemistry of air and water. It was not a strike from beyond, but a convulsion from within, as though the planet itself had turned against its children. Some scientists wonder whether asteroid impacts and supervolcanoes are not rivals, but partners in destruction. Both possess the power to tip Earth's climate into chaos, to smother sunlight, to poison the air. Both can reach across continents, binding land and ocean in chains of death. But in scale and persistence, the Siberian traps hold supremacy. Their eruptions dwarf any impact in sheer duration and in the volume of gases released. Chicxulub ended an empire of dinosaurs. The Permian nearly ended life itself, and yet, behind these catastrophes lies another player, more silent but equally decisive: the arrangement of continents. During the late Permian, the world was gathered into Pangaea, a single, sprawling landmass ringed by a global ocean, its vast interior baked under scorching heat, while its coasts endured violent storms and shifting monsoons. Such a configuration amplified extremes: droughts deeper, floods heavier, ecosystems more fragile. When volcanism struck, the stage was already set. Earth was primed for collapse. In laboratories today, supercomputers attempt to resurrect these vanished worlds. Equations of fluid dynamics recreate ancient winds. Chemistry models restore the breath of extinct atmospheres. In silico, oceans fill with stagnant layers. Skies turn acidic and temperatures soar. These simulations confirm what stone and fossil whisper: that Earth can, under the right conditions, become alien to its own life. The comparisons are uneasy. When researchers speak of the Permian, echoes of the present creep into their words. Carbon rising at rates unseen in millions of years. Oceans warming, losing oxygen, their circulation slowing. Forests stressed, reefs unraveling. It is not the same. Humanity is no Siberian traps, no mantle plume tearing through the crust. Yet the fingerprint is hauntingly familiar. A world destabilized by carbon, tipping toward thresholds it has crossed before. To confront this parallel is to stand at the edge of science and philosophy alike. For what the record shows is not only catastrophe, but recurrence. The Permian was not the only mass extinction. It was the greatest, but not the last. Each great dying reveals a truth that is as unsettling as it is profound. Earth possesses reset buttons, mechanisms buried deep in geology and climate that, once triggered, reorder life on a planetary scale. The question, whispered in fossil beds and simulated in the silent hum of supercomputers, is whether humanity now lives in the shadow of another such reset. The Permian teaches not inevitability, but vulnerability, that the balance of habitability is delicate, and that survival is neither permanent nor guaranteed. Life endures, but not always as it was. The great dying is remembered not only for its magnitude, but for its warning, that Earth, so long our home, can at times become unrecognizable. And if it has happened before, the haunting possibility remains. It can happen again. The Ordovician extinction, long before dinosaurs and even before forests, was the first great trial. Then glaciers advanced across Gondwana, locking oceans into ice. Sea levels fell, shallow habitats vanished, and nearly 85% of species disappeared. It was a reminder that climate alone, shifting by degrees, could rewrite the architecture of life. No firestorms, no poison skies, only the quiet grind of ice reshaping the world. The Devonian extinction, hundreds of millions of years later, unfolded not in an instant, but as a drawn-out decline. For tens of millions of years, biodiversity eroded. Giant reefs, once thriving with corals and sponges, crumbled into dust. Plant life, newly spread across continents, may have triggered it, drawing carbon dioxide from the air, altering weather and draining nutrients into seas. Algal blooms poisoned waters, oxygen vanished, and ecosystems faltered. It was not violence, but imbalance, that undid much of life's complexity. The Triassic extinction, following the Permian, came in the wake of recovery. The world had struggled, back from its near annihilation, only to be thrust once more into chaos. Again, volcanism was to blame, this time from the central Atlantic magmatic province, a volcanic system stretching across what would become the Atlantic Ocean. Carbon flooded the atmosphere, climates destabilized, and nearly half of species vanished. Yet, in that loss, opportunity emerged. The survivors included the small, nimble reptiles that would rise as the dinosaurs dot. Each of these events whispers variations on the same theme. Catastrophe is not rare in Earth's history. It is cyclical, woven into the planet's geology and climate. Ice fire, impact, imbalance, all have taken their turns as executioners of species. What makes the Permian unique is not merely scale, but the completeness of its vision. It was an apocalypse that seemed determined not to prune the tree of life, but to tear it up by its roots. Modern science, armed with satellite data and deep-sea probes, now compares these ancient deaths with the unfolding present. The rates of change differ, but the signatures rhyme. Acidifying oceans, warming climates, shifting currents, declining oxygen, all of these are seen today, not as speculation, but as measurement. Humanity, though small in geologic time, has already left marks discernible in the same language. Of catastrophe written in stone, supercomputers show how close thresholds can lie. A subtle shift in circulation, a minor warming in one ocean layer, a fraction less oxygen and feedback loops ignite. Anoxic seas breed microbes, microbes release. Toxins, ecosystems unravel. In the Permian, these cascades amplified over millennia. Today, with carbon rising faster than in that ancient crisis, the timeline may be compressed into centuries, and yet, unlike trilobites or Permian forests, humanity possesses foresight. The fossil record is no longer mute, it is a guide. In the Ordovician, ice claimed the seas. In the Devonian, plants remade the air. In the Triassic, volcanism carved new continents. Each extinction was a lesson in fragility. The Permian, however, remains the most chilling lesson of all, that even the mightiest biosphere can collapse when planetary systems are driven beyond their thresholds. Earth's past speaks with the voice of inevitability. The reset buttons exist. They have been pressed before. The unsettling mystery is not whether they can be pressed again, but whether, in our age, one is already being nudged toward activation beneath the frozen soils of Siberia. 252 million years ago, a wound in Earth's crust tore open a scar that would not heal for nearly 1,000,000 years. The Siberian Traps, a vast volcanic province, began to disgorge fire on a scale unimaginable to modern eyes. Curtains of lava stretched for thousands of kilometers, burying landscapes, building mountains of basalt, and pouring gases into the skies without pause. This was not a single eruption, not a fleeting burst of fire, but an age of burning, a relentless outpouring that dwarfed anything humanity has ever witnessed. With each pulse of magma came carbon dioxide and sulfur dioxide. Billions of tons released into the air. The skies thickened with haze, sunlight dimmed, and acid clouds rained upon the land. Forests blackened, soils leached, rivers turned corrosive. What grew lush under the Devonian sun was now stripped bare by chemical storms. Life on land faltered. Its foundations gnawed away from both earth and sky. But it was the oceans, Earth's ancient womb, that bore the deepest scars. Carbon dioxide dissolved into the seas, transforming them into vast reservoirs of carbonic acid. Coral reefs, once thriving metropolises of biodiversity, dissolved as their skeletons melted away. Plankton, the architects of food webs, withered under the weight of acidity. With their fall came the collapse of the marine chain, a domino effect, cascading from the smallest organisms to the great predators that ruled the waters. As surface life faltered, the deep seas suffocated. Volcanic warming slowed the turnover of ocean currents, locking waters into stagnant layers. Oxygen bled away, replaced by hydrogen sulfide from blooming microbes. A silent poison spread upward, leaving vast stretches of the seafloor barren. This state, oceanic anoxia, was not a temporary episode, but a lingering suffocation lasting thousands of years. The seas that had nurtured life for billions of years now became graveyards, hostile to nearly everything that swam, crawled, or grew within them, and yet the story deepened still. The fires of Siberia did not merely poison the skies and seas, they awakened forces buried within Earth itself. Permafrost thawed, clathrates shattered, and methane, a greenhouse gas far more potent than carbon dioxide, escaped in violent bursts. A runaway feedback ignited. The hotter the climate became, the more methane surged into the atmosphere, amplifying the very furnace that released it. The planet entered a vicious cycle, spiraling toward extremes. The Permian Earth was no longer a world of balance. It had become a self-amplifying machine of destruction. Each shift triggered the next. Volcanism drove warming, warming released methane. Methane intensified the greenhouse, the seas suffocated, and life unraveled. This chain of feedback transformed disaster into catastrophe, catastrophe into cataclysm. Fossil records and geochemical fingerprints bear witness to this descent. Layers of rock show spikes of carbon isotopes, abrupt collapses. In biodiversity, sudden disappearances of entire families of creatures. In each strata lies the imprint of cascading loss. A portrait of a biosphere collapsing, not by chance, but by design of Earth's own feedbacks, pushed beyond their limits. The devastation lasted not days or centuries, but millions of years. Even after the last flames of the Siberian traps dimmed, the planet remained locked in chaos. Oceans stayed lifeless, climates swung between extremes, recovery stalled again and again. The Permian extinction was not a single event, but an era of destruction, a slow-motion collapse where Earth itself turned hostile to its own creation. This was the world's most profound reckoning, a reminder that the planet is not merely a stage for life, but an active force, capable of nurturing and capable of annihilating. In the great dying Earth revealed a darker face, one that could bend the course of evolution and nearly erase the story of life itself. The scars of the great dying did not etch themselves in silence. They were written into stone, into the chemistry of ancient oceans, into the vanished record of life itself. Each fossilized reef, each layer of black shale, is a frozen testimony to the machinery of destruction that consumed Earth. And as scientists sift through these fragments, a pattern emerges, a pattern of relentless feedback, a system that seemed determined to collapse upon itself. The Siberian traps were the trigger, but they alone cannot account for the sheer completeness of the devastation. It was not only the direct impact of lava and gases, but the consequences they unleashed across the globe. Models of the ancient atmosphere, reconstructed by geochemists and tested on supercomputers, reveal staggering numbers. Carbon dioxide levels may have risen to more than 10 times modern values, enough to heat the planet by 8 to 10 degrees Celsius on average. For perspective, modern climate science warns that a rise of just 2 degrees will reshape human civilization. The Permian surge was not merely a warming, it was a planetary fever, one from which ecosystems could not recover, and as the fever spread, the oceans became its greatest victim. Without oxygen, the seas turned toxic. Hydrogen sulfide, the rotten egg gas of microbial death, may have risen from the depths, spreading across continental shelves in lethal clouds. Some models even suggest it may have reached the air, bleaching skies with greenish haze, poisoning plants, and further destabilizing the atmosphere. In this vision, the Earth itself became alien, its air unbreathable, its seas uninhabitable, its soils stripped of fertility. The fossil record reveals the toll with brutal clarity. Insects, the great survivors of evolutionary history, nearly vanished, the only known mass extinction in their long reign. Coral reefs collapsed entirely, not to recover for millions of years. Trilobites, ancient denizens of the seas, disappeared forever, their lineage ending in silence. Even forests withered, leaving behind horizons of fossilized ash and charcoal, mute witnesses to landscapes where no life could take root. Yet the catastrophe was not instantaneous. Evidence points to a drawn-out collapse unfolding in pulses and waves. Some species struggled on for thousands of years, only to be swept away by the next surge of heat or anoxia. Others adapted briefly to new conditions, only to find themselves trapped when feedback loops worsened. It was not a clean break, but a grinding attrition, a slow erasure of life's possibilities, until only a fraction remained. And when recovery did begin, it was hesitant, fragile, and painfully slow. For nearly 5 million years after the initial extinction, biodiversity remained crippled. Evolution stumbled, repopulating ecosystems with simple, hardy forms while complexity lagged far behind. The scars of the Great Dying lasted far longer than the eruption itself. They shaped the course of life for the entire Mesozoic that followed, dictating which lineages would rise and which were lost forever in the starkest sense. The Siberian traps demonstrated that Earth is not a passive host. It is an engine capable of driving itself into chaos, of amplifying its own destruction through the very systems that normally sustained life. The Great Dying was not merely a tragedy of lost species, but a revelation, a reminder that life's stability depends on a fragile equilibrium, one that can unravel when the planet's cycles are pushed too far. The Permian extinction remains the most chilling example of Earth's self-amplifying power. But as scientists gaze deeper into its mysteries, they cannot help but ask, could such a chain of destruction ever awaken again? The Great Dying remains the most devastating mass extinction in Earth's history. Yet even with the colossal scale of the Siberian trap's eruption, even with oceans poisoned and skies thickened with carbon, some scientists still wonder, was volcanism alone enough to erase 90% of life? Or was there something more, a hidden hand, cosmic or terrestrial, that deepened the wound? Among the speculative and fringe theories, one possibility lingers with quiet unease: impact. The Chicxulub crater in Mexico stands as testimony to the destructive power of asteroids, ending the age of the dinosaurs with a single blow. Could the Permian extinction have had its own hidden impactor, a crater now buried beneath millions of years of shifting crust? Some traces suggest yes. Tiny spheres of once molten rock, shocked quartz with microscopic scars. Even scattered chemical anomalies have led researchers to suspect that an asteroid or comet may have struck Earth around the same time, but the evidence is incomplete, uncertain, and contested. Unlike Chicxulub, no vast crater has yet been found. If such a scar exists, it may lie beneath the ocean floor, swallowed by the movements of tectonic plates, erased by time's relentless hand. Others cast their eyes not to Earth's surface, but to the stars. A nearby supernova could have bathed the planet in lethal radiation, stripping away protective ozone and exposing life to ultraviolet death. Even more chilling, a gamma-ray burst, the violent cry of a collapsing star, could sterilize a hemisphere of Earth in moments, leaving behind no crater, no direct trace, only the pattern of extinction itself. Though improbable in timing, the universe has never lacked for violence. If such an event did occur, it would explain the suddenness of collapse, a cosmic strike, invisible yet devastating, beyond the power of any terrestrial force to prevent. There are theories, too, that Earth's own heartbeat may have played a role. Some geophysicists speak of planetary breath, cycles deep within the mantle that surge with heat and pressure, releasing pulses of volcanism and upheaval at intervals across geological time. If such internal rhythms exist, then perhaps the Permian extinction was not a unique accident, but part of a grander cadence of Earth, itself a breath drawn too deep, exhaled with catastrophic force. More speculative still are ideas at the frontier of physics. Some have wondered whether dark matter, the invisible substance that makes up most of the universe, could interact with Earth in ways we barely comprehend. Passing through the planet in dense streams, could it alter the heat of the core, destabilize climate, or trigger volcanic chains? There is no evidence yet, only the echo of questions. But in a universe where the vast majority of matter is unseen, dismissing the unseen as impossible may itself be folly. And then there is the haunting possibility that no single cause is sufficient, that the Permian extinction was not the result of one catastrophe, but many, volcanism amplified by climate feedback, perhaps joined by an asteroid strike, perhaps accelerated by cosmic radiation, catastrophes overlapping in dreadful synchrony, each disaster feeding the next, until life's resilience could no longer endure. To consider these theories is to confront the fragility of existence. If the Permian extinction was inevitable, written into Earth's geology, into the cycles of stars, into the very structure of the cosmos, then life's endurance was never guaranteed. Perhaps every flourishing world carries within it the seeds of its own erasure, waiting for a convergence of forces too vast to resist. And yet the fact remains: life did endure. A remnant of species passed through the crucible, fragile but unbroken. From those survivors, new ecosystems arose, new experiments in form and function, new stories of resilience. The great dying may have revealed that extinction is inevitable, but it also revealed something else, that survival, however improbable, is equally part of Earth's story. The search for answers does not end with science alone. It drifts into philosophy, into questions that linger beyond data and fossil beds. For if the Permian extinction was not caused by a single, measurable event, but instead by a chorus of overlapping catastrophes, then perhaps it reflects something deeper about the nature of Earth itself. One vision sees the extinction as a cosmic accident, an unfortunate alignment of rare events. The Siberian traps erupting just as climate systems reached their breaking point, perhaps nudged by a stray impact or a pulse of radiation from the stars. In this telling, life was the victim of coincidence, crushed beneath the indifference of chance. Another vision is more unsettling: inevitability. Across geological history, mass extinctions seem to arrive like punctuation marks in the story of life, the Ordovician, the Devonian, the Permian, the Triassic, the Cretaceous, 5 great intervals when flourishing worlds collapsed. Could it be that Earth itself enforces these resets, not through malice, but through the restless mechanics of a planet that is never still? A biosphere too successful, too lush, may destabilize its own foundation, pushing climate and chemistry into chaos. Life itself becomes the architect of its own destruction. Here, the Permian extinction reads not as an accident, but as a kind of necessity, a recalibration of the planet's balance. In this light, Earth appears less as a gentle cradle of life and more as a mercurial stage where stability is always temporary and survival always provisional. The speculative theories only sharpen this unease. A gamma ray burst, sterilizing half the Earth in seconds, is unlikely, but not impossible. A hidden impactor might still lie buried beneath the deep oceans, waiting to be discovered. Unknown cycles in Earth's mantle may pulse with destruction, on timescales too vast for humanity to yet perceive, and the dark matter hypothesis, tenuous but haunting, reminds us how little is known about the forces that weave through the cosmos. If 95% of the universe is invisible to science, how many of its dangers remain invisible as well? Modern supercomputers allow researchers to peer backward, testing different scenarios with equations that simulate oceans, skies, and carbon cycles. Each run of these models tells a slightly different story. Sometimes volcanism alone suffices. Sometimes methane feedbacks dominate. Sometimes extinction seems inevitable only if multiple disasters are allowed to overlap. The truth may never resolve into a single cause. Instead, it may remain as the extinction itself was complex, layered, and immense. And perhaps that too is a lesson. Not every question will yield to science with clean simplicity. Some mysteries endure not because evidence is lacking, but because reality itself is tangled, chaotic, and unwilling to be reduced to one neat answer. For those who contemplate the Permian, this realization brings both terror and humility. If Earth has natural reset buttons, if mass extinctions are written into its geology and into the violence of space beyond, then survival is not a permanent state, but a temporary reprieve. Humanity, for all its power, may live under the same precarious laws that governed trilobites and ancient forests, and yet, in the ruins of every extinction, life has found a way forward. From the ashes of the Permian came the first ancestors of dinosaurs, the first steps toward mammals, the distant roots of every bird, every tree, every human who now wonders at the story. Extinction did not end life's journey, it reshaped it, forcing it into new directions, new forms, new experiments in resilience. The Great Dying is thus both a warning and a paradox. It shows how fragile life is, and how easily entire worlds can vanish. But it also shows that even in the deepest abyss, survival is possible. A handful of creatures endured, carrying forward the thread of existence into a future they could never foresee. The speculative theories may never be proven. The hidden asteroid may remain hidden. The gamma ray burst forever unconfirmed. The whispers of dark matter unresolved. But the questions they raise matter, because they remind us of the vast stage upon which life unfolds, a stage shaped by volcanoes and oceans, but also by stars, galaxies, and forces beyond imagination. In the end, the Permian extinction might not be explained by one answer, but by a constellation of them. Earth may be both victim and perpetrator, the universe both enemy and indifferent backdrop. And somewhere between inevitability and chance, life persists, fragile, improbable, yet enduring. It is here, in the space between science and mystery, that the true terror and wonder of the Permian lies. Beneath the frozen silence of Siberia, scientists drill into stone laid down in the wake of Earth's greatest catastrophe. Each core of hardened lava is a page torn from the most violent chapter of the planet's history. The Siberian Traps, a volcanic province vast enough to drown a continent in fire. These ancient rocks hold chemical signatures of the gases they released, traces of the poisons that turned seas to acid and skies to ash. By decoding their story, researchers seek to pin down not only the scale of the eruptions, but the tempo. Whether Earth's death came in a slow suffocation or in pulses of fury that shattered ecosystems in rapid succession. Far from these lava fields, another kind of record lies hidden beneath the oceans. Sediment cores pulled from the abyssal plains contain layered memories of a vanished world. Each thin stratum of clay, silt, and microfossil captures the chemistry of a moment long past. In these delicate layers, scientists read the fingerprints of anoxia oceans robbed of oxygen, turning from nurseries of life into stagnant graveyards. Tiny isotopic shifts whisper of methane released from melting clathrates, of carbon cycles spiraling beyond control. Even the shells of microscopic plankton, preserved for over 250 million years, reveal how quickly the base of the food chain collapsed, dragging the giants of land and sea into extinction with it. In laboratories, fragments of fossilized DNA and molecular remnants are yielding a different kind of testimony. While the majority of life perished, a few lineages endured. Small burrowing reptiles, hardy plants, and microbes that thrived where others starved. Their survival is written into the chemistry of ancient soils and the genetic echoes that persist in their modern descendants. By studying these survivors, science glimpses the strategies that allowed life to persist through Earth's darkest night. Resilience in the face of planetary collapse. At the heart of this search lies time itself. New high-resolution dating methods, using uranium-lead isotopes locked inside zircon crystals, have narrowed the extinction's chronology with astonishing precision. What once seemed a slow decline over millions of years is now seen as a catastrophe, compressed into tens of thousands, a geological instant. This revelation reframes the disaster, not a gradual fading, but a near-instant collapse of Earth's biosphere. Into this puzzle now steps a new ally, artificial intelligence. Machine learning models are beginning to weave together the scattered strands of data, volcanic gas emissions, ocean chemistry, fossil records, climate simulations. They reconstruct entire lost ecosystems, testing how webs of life unraveled and how feedback loops amplified the chaos. AI allows humanity to ask questions once impossible. What precise tipping points shattered the Permian world? How many days, years, or centuries stood between stability and ruin? Yet behind the science, a shadow grows. The more the Permian is understood, the more it speaks to the present. The gases that poured from the Siberian traps are not so different from the emissions now rising from smokestacks and engines. The chemical imbalance that choked the ancient seas finds echoes in today's oceans, where acidification and dead zones spread at alarming rates. The runaway warming of a greenhouse Earth, once a distant paleontological mystery, now reads like a warning carved into stone. To study the great dying is not only to uncover the past, it is to peer into a mirror, where Earth's ancient wounds reflect humanity's own trajectory. The Permian was a crucible that nearly ended life. Today, as climate systems strain under human influence, its memory returns as both prophecy and plea. The work of these scientists is more than an excavation of history. It is an act of vigilance, a race to understand how worlds collapse and how, if at all, they endure. The parallels between the Permian world and the present are not coincidences written lightly into history. They are threads that bind to distant ages together, separated by hundreds of millions of years, yet whispering the same warning. In the late Permian, carbon dioxide surged into the atmosphere at a rate far exceeding the planet's ability to absorb it. Oceans turned sour as carbonic acid gnawed at the shells of plankton. Oxygen dwindled from the seas, and the chain of life unraveled from its base upward. Today, scientists measuring modern oceans find eerie reflections, coral reefs bleaching, dead zones spreading, the chemistry of seawater shifting beneath the weight of human industry. The Permian crisis reminds us that Earth does not forgive imbalance. Its climate and ecosystems are not static, but sensitive, reactive, capable of swinging into states hostile to life. During that ancient catastrophe, average global temperatures rose by at least 10 degrees Celsius. The tropics became lethally hot, deserts expanded, and polar ice vanished. Now climate projections warn that unchecked emissions could push Earth toward its own destabilized future, not identical to the Permian, but rhyming with its grim refrain. Supercomputers simulate these possibilities with haunting detail. Models of atmospheric chemistry and ocean circulation, once designed to probe Earth's deep past, are now applied to the near future. They reveal thresholds beyond which warming accelerates, ice collapses, and carbon sinks transform into carbon sources. In the Permian, such feedbacks turned a catastrophe into a cataclysm, locking the planet into a runaway greenhouse state for millions of years. Humanity now stands at the edge of a similar precipice, though this time the trigger is not volcanic fire, but industrial civilization. Yet unlike the organisms of the Permian, humanity is not a passive witness to planetary forces. The very tools that unearth the secrets of the great dying, precision dating, genetic analysis, artificial intelligence, also illuminate the choices of the present. Scientists working on the deep past are not only reconstructing ancient climates, they are mapping the boundaries within which our own civilization can endure. Their findings carry a quiet urgency. The Earth system can be destabilized, and it has been destabilized before. The Permian extinction did not erase life, but it reshaped it beyond recognition. The few survivors became the architects of a new biological world, paving the way for the rise of dinosaurs, mammals, and eventually humans. This resilience is both a comfort and a warning. Life, in some form, will endure even through collapse, but whether humanity endures with it remains a question not yet answered. Every drill core pulled from Siberia, every isotope measured from ancient zircons, every algorithm reconstructing vanished ecosystems contributes to a story larger than science alone. It is a meditation on fragility, a recognition that Earth carries within itself the power to reset, to wipe its surface clean, and begin again. The Great Dying was one such reset, an event so vast it nearly emptied the stage of life. To understand it is to confront the scale of forces that shape worlds, and the reality that humanity, for the first time, holds in its own hands the capacity to unleash something similar, The chapter of the Permian does not close with certainty. Its pages are still being written in laboratories, on drilling ships, and in climate models. But already it has taught one lesson beyond doubt. Earth's stability is not guaranteed, and the cost of imbalance is measured not in years, but in extinctions, as the camera of history pans from ancient lava fields to present-day smokestacks. From the fossilized remains of Permian reefs to the bleaching corals of today, the line between past and future begins to blur. What happened 252 million years ago is no longer just a mystery to be solved. It is a mirror held to the present, a reminder that the greatest extinction in Earth's history may not remain confined to the past in the quiet mathematics of deep time. Life is both delicate and enduring. It flourishes in fragile balance, suspended on the edge of catastrophe, and yet it survives the unthinkable, reshaping itself after every fall. The Permian extinction was a reminder, written into stone, that abundance can vanish in an instant, and that the margin between thriving and annihilation is vanishingly thin. 90% of species disappeared, leaving behind not only silence but the possibility of something new. For in that darkness, evolution was given a blank canvas. The collapse of ecosystems tore down ancient dominions, but in their absence, new forms of life emerged. The survivors, lungfish and small reptiles, tenacious microbes and hardy plants, became the seeds of worlds yet to come. From there, resilience rose the age of the dinosaurs, and long after, the lineage that would lead to humanity itself. Without that crucible of death, the stage of Earth's story might have followed a different script, one in which neither dinosaurs nor mammals would have ever walked beneath the sun. There is a paradox here, one that unsettles as much as it enlightens. Mass death became the sculptor of future possibility. Catastrophe, though merciless, was also creative. The Permian extinction, in all its terror, was not merely an ending, it was also a beginning, a violent reset that carved space for life's next chapters. It asks a difficult question: is destruction an inseparable part of creation? Such reflections draw the gaze toward our own age. Humanity stands in a moment of unprecedented power, capable of altering the climate, the oceans, and even the chemistry of the air. The echoes of the Permian rise like a warning from the past. When balance is broken, the planet can respond with ferocity, turning abundance into desolation. The fragile thread that sustained life then is the same one that holds civilization now. And yet, unlike the creatures of that distant world, humanity carries foresight, the ability to look backward into deep time and forward into uncertain futures. This knowledge is both a gift and a burden. It reveals that Earth is not a passive backdrop, but an active force, a cradle and an executioner. A planet that creates worlds and erases them again and again. The Permian extinction lingers not just as a tale of death, but as a mirror. It reflects life's vulnerability, its resilience, and its dependence on planetary balance. It reminds us that survival is not guaranteed, and that every age of life eventually faces its test. For the Permian world, that test came in fire and suffocation. For humanity, it may arrive in the consequences of its own hand. The camera of history pulls back, revealing Earth adrift in the vast silence of space, a sphere of oceans and stone, fertile and merciless, ever reshaping itself. The story of the great dying is written in its rocks, but its meaning lives in the present. To flourish on this world is to walk always on the edge of disappearance, And to endure is to understand that every beginning is born from the shadow of an ending. Yet in the silence that follows such devastation, something profound lingers, the paradox of life itself. Out of nearly total annihilation, the tree of existence did not fall, but sprouted again, reshaped and redirected. From the ashes of the Permian, new creatures emerged, fragile yet resilient, carrying the seeds of future worlds within their bones. The stage cleared by death became the theater of evolution's most daring experiments. The ancestors of dinosaurs, once insignificant and overshadowed, seized their chance in the aftermath, rising into forms that would dominate Earth for nearly 200 million years. And much later, when their reign ended, the descendants of small nocturnal survivors, the mammals, stepped into the light. In this sense, humanity's own story is entangled with catastrophe. Without that great dying, without the world's darkest hour, perhaps we would never have come to be. It is a haunting realization. Extinction is not only an ending, but also a beginning. The Permian reminds us that destruction and creation are not opposites, but twin forces bound together in Earth's long narrative. Life thrives because it suffers. It expands because it collapses. Out of every silence, a new voice eventually rises, but this reflection carries a sharper edge when cast against the present. Today, scientists warn that humanity may be setting into motion a crisis that echoes the Permian in miniature climate disruption. Acidifying oceans, ecosystems unraveling at their roots. The difference is scale and speed. What once unfolded over thousands of years now trembles within centuries, even decades. The lesson is stark. Earth is both cradle and executioner, capable of nurturing life's greatest diversity and of erasing it with cold indifference. The planet endures. It is life that teeters on the edge. The Permian whispers a question across time. Will we learn from the past, or are we destined to become another footnote in its repeating story of collapse and renewal? And so the reflection closes where it began, with fragility. Humanity is but a thin flame flickering on the surface of an ancient world. To understand the Permian is to see not only how close life has come to oblivion, but how precious survival truly is.